In this video, we will discuss solving quadratic equations by the square root method. A quadratic equation is an equation in which at least one variable term is raised to the second power and no variable term has a power more than 2 or less than 0. The standard form of a quadratic equation is ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not equal to 0. Arrange the quadratic equations in standard form. 3x squared minus 3 plus 5x equals 0. The terms are out of order. Move the term 5x between the other two terms to get 3x squared plus 5x minus 3 equals 0. 7x minus 2x squared minus 8 equals 0. The terms are out of order. Move the term 7x between the other two terms to get negative 2x squared plus 7x minus 8 equals 0. 12 equals 7x squared minus 4x. The term 12 is on the wrong side of the equation. Subtract 12 from both sides of the equation to get 0 equals 7x squared minus 4x minus 12. Note, this is equivalent to 7x squared minus 4x minus 12 equals 0. 7x squared equals 3. The term 3 is on the wrong side of the equation. Subtract 3 from both sides to get 7x squared minus 3 equals 0. We could also subtract 7x squared from both sides to instead get 0 equals negative 7x squared plus 3, or negative 7x squared plus 3 equals 0. A quadratic equation is a second-degree equation, which means that it can have at most two solutions. Throughout this chapter, we will see quadratic equations with 2, 1, or 0 solutions. The standard form of a quadratic equation, ax squared plus bx plus c equals 0, has three types of terms. Ax squared is called the quadratic term. That is, the degree of the term is 2. In standard form, the quadratic term is the leading term, and a is the leading or quadratic coefficient. Bx is a linear term. That is, the degree of the term is 1, and b is the linear coefficient. C is a number term, or preferably a constant term. The degree of the term is 0, and the coefficient is c, because c equals c times x to the 0 power. A quadratic equation that has all three types of terms is a complete quadratic equation. If a quadratic equation has a quadratic term and a linear term, but no constant term, it is sometimes referred to as an incomplete quadratic equation. While an equation with a quadratic term and a constant term, but no linear term, is a pure quadratic equation. When solving quadratic equations, it is helpful to be able to identify the types of terms and the coefficients a, b, and c. Identify a, b, and c for each quadratic equation. 3x squared plus 5x minus 2 equals 0. Here, a equals 3, b equals 5, and c equals negative 2. 5x squared equals 2x minus 3. First, rewrite in standard form, 5x squared minus 2x plus 3 equals 0. Then a equals 5, b equals negative 2, and c equals 3. 3x equals 5x squared. First, rewrite in standard form, 5x squared minus 3x equals 0. Then a equals 5, b equals negative 3, and c equals 0 since there is no constant term. X squared equals 9. Rewrite as x squared minus 9 equals 0. Then a equals 1, since the quadratic term has no visible coefficient. B equals 0, since there is no linear term. And c equals negative 9. To solve pure quadratic equations, solve for the squared variable and apply the square root property of equality. Take the square root of both sides of the equation. To solve a pure quadratic equation, ax squared plus c equals 0. Rearrange the equation if necessary so that the quadratic term is on one side and the constant is on the other side of the equation. Combine like terms if appropriate. Rewrite the equation so that the quadratic term has a coefficient of 1. Divide both sides by a if necessary. Apply the square root property of equality by taking the square root of both sides. and check each solution in the original equation. For example, solve 3y squared equals 27. The first and second steps described in the previous slide are unnecessary here. We start by dividing both sides of the equation by a equals 3. 3y squared divided by 3 equals 27 divided by 3, so y squared equals 9. Taking the square root of both sides of the equation, we find y is equal to plus or minus 3. Now we test both of these values in the original equation. 3 times 3 squared equals 3 times 9, which is 27. 3 times negative 3 squared equals 3 times 9, which is 27. Both of the solutions check, so y is equal to plus or minus 3. Solve 4x squared minus 9 equals 0. We start by adding 9 to both sides, then dividing by 4. So 4x squared minus 9 equals 0. Then 4x squared equals 9. So x squared equals 9 divided by 4, or 9/4. Now we can take the square root of both sides to get y equals plus or minus 3/2. We check both of these solutions. 4 times 3/2 squared minus 9 equals 4 times 9/4 minus 9, which is 9 minus 9, which is equal to 0. 4 times negative 3/2 squared minus 9 is 4 times 9/4 minus 9, which is 9 minus 9, which equals 0. Both of the solutions check, so y is equal to plus or minus 3/2, which is equal to plus or minus 1.5.